So students, in the last lecture we have seen about change of variables for double integrals. That means we were changing the Cartesian coordinates x, y to u and v, and for that we require the concept of Jacobian. Jacobian means del xy by del u v. Okay, so if it is better to find out directly, then we can find it. Otherwise we can find out j dash. J dash means del u v by del xy. So you can find anything among these two, but you can find we require j, and if you want to find out j, then use j equal to 1 upon j dash. That we have seen, and also we have seen some of the examples. Now let us see more examples based on this. So example, evaluate double integration over r x square plus y square dA, where r is the region, lying in the first quadrant, and bounded by the hyperbolas, x square minus y square equal to 1, comma x square minus y square equal to 9, comma x into y equal to 2, and x into y equal to 4. Okay, so now let us solve this example. Here you can see that we are given the double integration, whatever it is, but looking to the region, you can see that these are given hyperbolas, and hyperbolas are difficult to draw, and so it is very difficult to determine the limits. So looking to the equations of the boundaries, that means regions, here we can see that the two equations have the symmetricities in terms of x square minus y square, and these two equations have also the symmetricities in terms of x into y. So here we will solve this problem by using the change of variables. Change of variables means, well, let us assume that u equal to, because to do change the variable we require another variables u and v. So we will have to assume the transformation, and these transformations we will determine from these four equations. So we will assume u equal to x square minus y square and v equal to xy. So if u and v are not given directly, then we can assume from the equations of the boundaries. Okay. So now after assuming these equations, we can see that these equations will become, what will become? Therefore u equal to 1, u equal to 9, this is v equal to 2, and that is v equal to 4. So here you can see that these equations have become very simple form. Okay, and so we can draw them directly. Otherwise no need to draw the figure over here, because limits of u and v you can put directly, u equal to 1 to 9 and v equal to 2 to 4. But here to proceed this we require the concept of Jacobian j. So Jacobian j is what? Del xy by del u. For that we require the derivatives of x with respect to u and v, derivative of y with respect to u and v. For that we require x and y in terms of u and v, but they are given in terms, u and v are given in terms of x and y. So here it is better to find out j dash. So therefore we will find out j dash. J dash means del uv by del xy, and this is what? Derivative of u with respect to x and derivative of u with respect to y in the first row. So with respect to x, derivative is 2x, and with respect to y it is minus 2y. Similarly, derivative of v with respect to x and y here, with respect to x is y, and with respect to y is x. So this gives us 2x square plus 2y square. Okay, that means 2 into x square plus y square. So actually we want to convert the whole problem in terms of u and v. So here x square plus y square also we need to convert in terms of u and v, and we need to put the value in of u and v for x square plus y square. But here x square minus y square equal to u, so we cannot put it directly and it becomes a complicated structure. Here also j dash, that means therefore j equal to 1 upon 2 x square plus y square. This also we need to convert in terms of u and v. But here you can see that this problem, when we will put here Jacobian j, then this x square plus y square and this x square plus y square will be cancelled automatically, and so no need to convert them in terms of u and v. So here we will have, this is x square plus y square, we will keep it as it is, into Jacobian j. Okay, Jacobian j du dv, you must be knowing. So here this is what, x square plus y square, Jacobian j is 1 upon 2 x square plus y square, and here it is du dv, and the limit, so this over r, so it has the integration, these two will be cancelled, so 1/2 we will take outside, so du dv only, and u has the limit 1 to 9, we can see 1 to 9, and v has the limit 2 to 4. So 1/2, here u and v are separated, these limits are also constant, so we can do this into u du, that means u has the limit 1 to 9 and v has the limit 2 to 4. So we can find out this by using 9 minus 1, that means 8, and this is 4 minus 2, that means 2. So the answer is 8. So we can find out the answer very easily for this problem, instead of solving directly, because direct solution becomes very complicated. So here you can see the use of change of variables, how the problems can become simple. So you write down this solution. Now let us see another example. Evaluate double integration y minus 4x upon y plus 4x over the region R dA, where R is the region bounded by the lines y equal to 4x, comma y equal to 4x plus 2, y equal to 2 minus 4x, comma y equal to 5 minus 4x. So here again in this problem, nothing is said that you change the variables, but looking to the function here, over here, you can see that the integration is very complicated. If you want to integrate with respect to x, or if you want to integrate with respect to y, in both cases it becomes very complicated. So we go for the second chance, that means whether it is possible to change the variables. So look at the equations of the curves. Here you can see that these two equations here we can have y equal 4x, y equal 4x plus 2. So we can write down y minus 4x. So y minus 4x equal to 0 and here y minus 4x equal to 2. So solution is possible by using change of variables. That means we will take u equal to y minus 4x. Okay. And here also you can see in both equations we will have y plus 4x. So we will assume v equal to y plus 4x. And therefore what will happen? This equation will become u equal to 0. This equation will become u equal to 2. This equation will become v equal to 2. And this equation become v equal to 5. So here again the limits are very easy. U has the limit 0 to 2. V has the limit 2 to 5. If you draw the figure, you will get the same limit. Because they are all are straight lines. They all are straight lines. So in UV plane we can get a square or rectangle, and the rectangular figure is there. Then the limits can be as it is, whichever the value, whatever the values of U and V are over here. Okay. And therefore now we need to find out Jacobian J. But here it is better to find out J dash. J dash means del UV by del xy. Okay, so del uv means in the first row derivative of u with respect to x and y. So its derivative with respect to x is minus 4, with respect to y is 1. Similarly here in second row the derivative of v with respect to x is 4 and derivative of v with respect to y is 1. So this is what? Minus 4 minus 4, that means minus 8. So this implies that what is j? J equal to 1 upon j dash, that means minus 1 upon 8. Okay, and therefore our problem now will become I equal to, here double integration y minus 4x, but y minus 4x is u, you can see, y plus 4x it is v, and it is modulus j du dv over r, and therefore we will have double integration u upon v modulus j, that means 1 upon 8 now, du dv, and here u has the limit 0 to 2, you can see, and v has the limit 2 to 5. Okay, so 1 upon 8 we will take it outside. Here constant limits are there, u and v are separated, so we can do it in a single step. So u has the integration u square by 2, it has the limits 0 to 2, and 1 upon v has the limit log of v, so it has the limits 2 to 5. So 1 upon 8, this is what? 4 by 2. 4 by 2 means 2 minus 0, and this is the limit log of 5 minus log of 2. Okay, so this is 2 by 8 means 1 by 4. Log of 5 minus log of 2 means log of 5 by 2. You know log of x upon y is log of x minus log of y. So this is the required answer. You can see. So now all of you note down this solution, because during the remaining time of this lecture you will have to re-practice all these examples, and all these examples are very easy to solve. let us see one more example. One more example. Evaluate integration, double integration. One is from 0 to 4, second one is from y by 2 to y by 2 plus 1, and here the function is 2x minus y open to dx dy by applying the transformation u equal to 2x minus y by 2 and v equal to y by 2. Okay. So now solution. So here we are directly given u equal to 2x minus y by 2 and v equal to y by 2. So here z dash is better to obtain. Z dash means del ue by del xy as we were finding, and it is the determinant. In the first row, derivative of u with respect to x and y. Derivative with respect to x is here 2 by 2, that means 1. Okay. Then derivative with respect to y, it is minus 1/2. Then derivative of v with respect to x, it is 0 because x is not involved, and derivative of v with respect to y, it is 1/2. So its value is 1 into 1/2 is 1/2 minus 0, that means 1/2. This is the Jacobian, and therefore j is 1 upon j dash, that means it is 2. Okay. Now after that, what will we do? Here 2x minus y by 2, this can be put directly u into Jacobian j du dv. But limits will also change. Here we are not given the region directly. Instead of this, we are given the limits. Therefore, here we will write down first that what is given us. These are the limits of x. That means x equal to y by 2 and x equal to y by 2, x equal to y by 2 plus 1. These are the limits of y, that means y equal to 0 and y equal to 4. So when x equal to y by 2, then we will convert this in terms of u and v. So here u is 2x minus y. So it can be written as 2x minus y equal to 0, you can see. Okay. So that means u equal to 0 we can get. Actually we need to convert all the equations in terms of u and v. This is converted in terms of u, either in terms of u, in terms of v, or in combination of u and v. So this is also, you can see that 2x minus y equal to 2. Okay, 2x equal to y plus 2. That means 2x minus y equal to 2. So u is 2x minus y by 2. So 2x minus y equal to 2. So 2 by 2. That means u equal to 1. You can see, you must see, you can observe this is converted in terms of u. Then we have y equal to 0. Y equal to 0 we can also put over here, but this we get u equal to x. Instead of this, if we put y equal to 0 over here, we can get v equal to 0 directly. So if both contains x, then we can mix both equations, so as we can get the combination of u and v. But here we are getting the directly equations in terms of u and v. So y equal to 4. So if we put y equal to 4 here, 4 by 2 to 4, that is v equal to 2. Therefore, our integration will now become 2x minus y by 2, this is u, into modulus j du dv, okay, over r. So here u modulus j is what? 2 into 2 and into du dv, okay, and we want to determine the limits of u and v. Here all the values are constant, in constant form, 0, 1, 0, 2. So we can write down the values directly. u has the limit. Here we have written u dv, so we will write the limits of u first. So 0 to 1, here are from 0 to 2, and 2 can be taken outside. So here its integration will be u square by 2. 2 we take outside. So 0 to 1 is the limit. Here dv is only there, so v is the limit 0 to 2, and you can find out the answer. Suppose if we draw the figure in UV plane, what will happen? U equal to 0 means v axis, okay? U equal to 1 means this is the line, u equal to 1, okay? So v equal to 0, v equal to 0 means u axis. V equal to 2 means from 1 to, this is the line v equal to 2. So this is the region. Why? Because this line is given as a boundary, this is given, this is given, this is given. So this is the boundary. So if you take a straight line parallel to x-axis, its endpoints, you can see that this endpoint lies on this curve where u equal to 0, and that's why we have substituted u equal to 0 here. And this endpoint lies on this line, so u equal to 1. And on v-axis, we have v equal to 0 to v equal to 2. Okay? So this is what that we have obtained the solution. You can find out its value by substituting 1 by 2 and so on. So you will get answer 2 over here. So you again note down this solution. So now let us see another topic in double integral, change of order of integration or change of limits of integration. So here always in examination one example comes based on this type. That means it can be asked in either in the form of solve the problem by changing the order of integration or solve the problem by changing the limits of integration. That means what do we have to do? Suppose here we are given the limits of the integration f of xy dx dy. So these are the limits of x, that means phi 1 by 2, phi 2 y, and these are the limits of y, that means suppose c to d. Then the basic concept is that here in the given example the order of integration is that first we need to integrate with respect to x, and secondly we need to integrate with respect to y. Okay, this is the order, this is the given order of integration or given limits of integration, you can see. But here sometimes you can observe the problem where if we want to integrate directly with respect to x in the given order, then it becomes very difficult to integrate this function. So instead of this, if you observe, instead of with respect to x, if we integrate with respect to y, then it may become very simple to integrate this function with respect to y. So it is better in this case that if you integrate with respect to y, then we can solve the problem very easily. Okay, so we can convert this problem in terms of this problem by writing it as dy dx. That means we are changing this order of integration. Now we will integrate this with respect to y, then with respect to x. But here you can see that when we change the order of integration, then the limits will also change. Limits will also change. You cannot write here that these are phi 1 y to phi 2 y and these are c to d. This is not proper way. This is incorrect. You cannot write these limits. Limits can be determined, and already we have seen this kind of examples indirectly. That means we have seen the examples at the starting of the chapter that if we solve a problem, same problem by taking a strip line parallel to x-axis and then parallel to y-axis. In both cases the limits were different but the answer was same. So here we will have to follow the process of determining the limits by drawing a figure. And so here the limits of integration, the limits of y will now be psi 1x to psi 2y, psi 2x, and these are the limits from a to b. These limits will be changed. Limits will also change. So it is not easy task to write down dy dx instead of dx dy directly. Limits will also change. So main task is to change the limits. So here change, it can be known as change the order of integration or change the order of change the limits of integration. So you will see such a case by considering one example. Let us see. Example: evaluate integration 0 to 1 integration x to 1 sin y square dy dx. So here you can see that it is written dy dx, and also these are the limits of y, that is y equal to x to y equal to 1. So the first integration is with respect to y, but sin y square has integration. The integration is not easy task because here y square is involved. Instead of this, if we could integrate this with respect to x, then this will remain constant. So only 1 is here. So the integration with respect to x is possible at the first level. Okay, at the first level. So we can integrate first with respect to x, then it is better. So we can write down now dx dy, but with the same, these limits will also change. So we will have to follow the procedure mainly for the change of limits. This can be, there is no problem. Here we will have to write down dx dy. This is this you can do very easily. But main task is to determine the limits. So these limits can be determined from the given limits, because these are the values of here y equal to x and y equal to 1. From this one, x equal to 0, x equal to 1. Okay, x equal to, and in polar coordinates also we have done this kind of situation. That means when we were converting into polar coordinates, the Cartesian problem into polar coordinates, then we were drawing the figure from the given limits. So here we will require to draw the limits. Figure is very much important over here. X, y, here y equal to x. Y equal to x is the line passing through origin. So here you give the name of this line. Y equal to 1 means at the point 1, it is the equation y equal to 1. So this is point 1. X equal to 0. X equal to 0 is nothing but y axis. That means this line. And x equal to 1. X equal to 1 is the line parallel to y axis passing through 1. But where is 1? You cannot draw in a assumed way anywhere. Before of that, just find out this intersection point. This is the intersection of these two lines, y equal to 1 and y equal to x. So if you put here y equal to 1, here you will get x equal to 1. So this is the point 1 comma 1. So here you can see that it is x equal to 1. So x equal to 1 line will pass through this point. So if you without understanding, if you draw x equal to 1 over here or x equal to 1 here, then it will give us strange results. So now see, which region will be considered? Either this region or the whole region. This region we cannot consider because this boundary is not given. It is simply x-axis, but in this boundary is not given. In this region we can consider because this boundary is given, this boundary is given, this boundary is given, and this boundary is given. So this is the region that we can consider. Now we change the order of the limits. Therefore now the limits are here we want to integrate first with respect to x. So we will have to write down this situation. We will draw a straight line parallel to x-axis. Here you can see the procedure is same of determining the limits. The two endpoints. This endpoint lies on y-axis. That means on y-axis x equal to 0. So here we have written x equal to 0. This endpoint lies on y-axis. This line. It has the equation y equal to x. So x equal to y. Then the limits of y. To determine the limits of y, look at y-axis. On y-axis, the whole region lies between these 2 points. You can see between these 2 points, where here y equal to 0 and here y equal to 1. So these are the limits. And therefore, our problem will now become sin y square. Here we will write down now dx dy, and these are the limits of x and these are the limits of y. So now the integration will become, what will be the integration? Here sin y square is constant, so we will take it outside. And only dx. So dx has the integration x 0 to y dy. So now 0 to 1, this is what? Sine of y square, and this is what? Y minus 0. So I will write down y over here, y into dy. So now the integration with respect to dy is possible because the derivative of y square is 2y and 2y is already there. 2 is not there, but we will write down here 1/2 to adjust the constant. And always I told you that the constants can be adjusted but variable cannot be adjusted. That means if y is not here, then you cannot write here 1/2y. It cannot be adjusted with the variable. It can be adjusted with the constant only. So now sin y square has the integration minus cos of y square, same as the integration of sin x cos x. Okay? So this is 0 to 1. And if you are confusing in this integration, you can try to find out its derivative. Its derivative should be same as this one because derivative of cos is minus sin y square. And the derivative of 2y is 2y. Y square is 2y. So it is the same thing. So it has the value. Now we put y equal to 1 here, then it is cos 1 minus cos 1. Then if we put 0, then it will be plus. And cos 0 is 1. Okay? So this is the value. Cos 1, you keep it as it is. You keep it as it is. Okay? So this is the required answer. You can see. So you write down this example. Okay, now I will rub it out. Now, let us see one more example. Evaluate integration 0 to infinity x to infinity e raised to minus y upon y dy dx by changing the order of integration. By changing the order of integration. So here in examination mostly you will be asked to this kind of sentence by changing the order of integration. So if this is asked, then you must have to follow this procedure. Either if it is integrated directly or not directly, you must have to change the order of integration. But if it is not written, then the decision is yours. If it is possible to solve directly, you can solve it directly. If it is not solvable directly, here we can see that e raised to minus y upon y has not the integration with respect to y directly. So we must require to change the order, because if we integrate with respect to x, then this will remain as constant. So only one will be there, and the integration is possible with respect to x. So here it is asked, so we must have to do. Otherwise, if it is not asked, then also we must have to follow the procedure of changing the order of integration. So here, what is given? We are given the limits of x, that means y. Actually, we can also write this as y equal to x and y tends to infinity. Or otherwise, we can also write the same thing as x less than or equal to y less than infinity, and this as 0 less than or equal to x less than infinity. Okay, and from this we will, and therefore the limits are we will have to draw the figure. What do we want to find? The limits we want to find is the first limits of x, then the limits of y, because now we want to integrate first with respect to x. So here we will have to draw the figure, and as I told you, figure is very much important. So here y lies between x and infinity, that means between y equal to x and y equal to infinity. So y equal to x is this line, okay, and y tends to infinity. Y tends to infinity, this means at infinity this is the line parallel to this one, okay. So actually it cannot be drawn directly, so we can show this by means of dotted line. So whereas we can understand this, that it is tending to infinity. X lies between 0 and infinity. So x equal to 0 is what? Y-axis. And x tends to infinity is what? It is also line on right hand side parallel to y-axis. So it is also at infinity. So this is also infinity. So which region will be considered? This cannot be considered because this boundary is not given. Actually it is x-axis but not given. This boundary is given, this boundary is given, this boundary is given, this is at the point infinity. So we will consider this as our region. Okay. Now we want to determine the limits with respect to x. So we will draw the straight line parallel to x-axis. So here x is what? On y-axis x is 0. You can see. On y-axis x is 0. And here what is x? It lies on this line, y equal to x. So there x equal to y. Okay. And what about y? For that we will have to look at the y-axis. So the whole region lies between y equal to 0 and up to infinity. So 0 to infinity. So here we will write down less than. And therefore our problem will now become, this is e raised to minus y upon y, and now we will write down here dx dy. X has the limit 0 to y and y has the limit 0 to infinity. So the integration is very easy now. E raised to minus y upon y is constant, so we can take it outside. Dx has the integration x 0 to y dy. Okay. Now you can see this one. So what will happen now? It is 0 to infinity. E raised to minus y upon y. This is what? Y minus 0. That means y dy. And this y and y will be cancelled. So only e raised to minus y is there. And e raised to minus y has the integration e raised to minus y upon minus 1. You can see. And this is 0 to infinity. So if we put infinity here, y equal to infinity, then e raised to minus infinity. But e raised to minus infinity is 0. Then we put 0, y equal to 0. So when we put y equal to 0, lower limit, then 1 minus sign will come here, or one more minus sign is there. So plus e raised to 0 is 1. So the answer is 1. Okay. So you must have observed that the procedure of changing the order of integration is very simple. Okay. So Here you write down this solution, and meanwhile you can here you can during the remaining time of this lecture you can solve all the examples which I have solved on the board during this lecture, and you can practice yourself. So all of you will be very much clear with the solving procedure of double integral problems. If any kind of problem is there, now you may be observing that you must have developed your capacity of solving double integration problems. In the next lecture, we will see more examples based on change of integrations, change of order of integration, or change of limits of integration problems, and then we will move forward to the concept of triple integration. Till then you can get practice of these examples. Okay, thank you.